In this video, I'm going to solve a problem of merging two sorted linked lists. This is an easy question frequently being asked in the interviews at FANG or MAANG interviews, which includes Meta, Microsoft, Apple, Amazon, and Google. So the problem statement is that you'll be given two heads of the sorted linked list, L1 and L2, or list 1 and list 2, and you need to merge these two sorted lists into one sorted list. And you should do this by splicing together the nodes of the first two lists. Okay, so here is an example. The first linked list is 1 to 4. It is sorted in increasing order. Second list is 1, 3, 4, and this is also sorted in increasing order. Now the merged linked list should have one of the first or second, whichever you pick. So it takes one of the second linked list, one of this first linked list, because they are equal, so it doesn't matter which one goes first. Then comes two of the first linked list and three of the second linked list, and then four of the first linked list and four of the second linked list. So that's how you resolve the sorted linked list. Now let's say if the first linked list was just 100 and second was 1, 3, 4, then the output should be 1, 3, 4, and then 100 of the first linked list. And if both are empty, the response would be empty. If one of them is empty and the other one is not empty, the result would be the whole non-empty linked list. And the constraints are the number of nodes in both lists is in the range of 0 to 50, and the values of the nodes could be -100 to +100. And both list 1 and list 2 are sorted in non-decreasing or increasing order. Let me start solving the problem. So the first thing is that I need a linked list that will hold the merged nodes. Once I have the new linked list that will hold all the merged nodes, I need to iterate through both the linked list 1 and 2, and I need to iterate until one of them is not empty, right? And then while iterating, I take the value, and whichever is smaller out of those two linked lists, I take that value and make that a next node of my new linked list that I created. Okay, so I keep going like that until one of them is empty. Now when one of them is empty, I take whatever is left from the one that is not empty, or not null basically, and then take that and make the tail of the merged linked list. So that's my approach. And let's see the implementation. So I first list node is what this code is providing. So I'm going to create list node merged head equals to new linked list or list node, and it can take any number, it doesn't matter. This is just to hold the merge list, and then I'll remove the head later and just keep the tail. So now while, as I said, I need to iterate over both list 1 and list 2 until they are not empty. List 1 is not null and list 2 is not null, right? So I iterate over list 1 and list 2 and check which one of list 1 and list 2's nodes are or has smaller value, right? So if list 1 has smaller value or equals to that list 2 that val, then I will add that value to my merged head or merged node, merged root, whatever I call it, list 1. And then because I use my list 1, I need to move the pointer for list 1. So list 1 now becomes the list 1 dot next. Alright, else if list 2 is smaller than list 1, then I add list 2 as the next pointer of the merge node, and I move the pointer for list 2. As I do that, I also need to move the pointer for the merged head, so I need a variable to keep the pointer on merged head. So I'm going to call it list node merged head pointer equals to merged head. This is just a pointer I'm going to use to keep moving the merged head pointer. Because that's where I'll be adding my next value. Sounds good. And then at the end, when one of them is empty, I will exit the loop and find out whichever is empty. If list 1 was empty, then I'll add list 2, or let me do, if list 1 was not null, then I will append merged head pointer that next equals to all of the list 1. Okay, that's all left. Otherwise, I will add merge head pointer that next equals to list 2, because it's not, there are some elements left in list 2. And with that, this would give me merged values in my merged head, but I don't want the first node, so my final result would be merged head dot next. Now let me run it. I think I need to use the pointer, not the head here, which is my bad. Alright, this goes green. So you can see that my input was 1, 2, 4, 1, 3, 4. The output should be 1, 1, 2, 3, 4, 4, 1, 1, 2, 3, 4, 4. And the other input was empty and empty. Output is empty. And the third input was, one of them was empty and the other non-empty, so it should give me back the non-empty value. Yep. Alright. So if I submit it, awesome, this is accepted, and this beats 100%, takes 42.58 megabyte, beats 34.33% in memory. So the complexity wise, this is O of n, because m or n actually, because you can see that I'm iterating over the linked list here until the smallest of them, basically, whichever is the smallest. And space wise, this takes O of 1 because I'm using a new merge head linked list, but that is still pointing to the existing list, so it shouldn't take extra space.